The science delusion is the belief that science already understands the nature of reality in principle, leaving only the details to be filled in. This is a very widespread belief in our society. It's the kind of belief system of people who say, I don't believe in God, I believe in science. It's a belief system which has now been spread to the entire world. But there's a conflict in the heart of science between science as a method of inquiry based on reason, evidence, hypothesis, and collective investigation, and science as a belief system or a worldview. And unfortunately, the worldview aspect of science has come to inhibit and constrict the free inquiry, which is the very lifeblood of the scientific endeavor. Since the late 19th century, science has been conducted under the aspect of a belief system or worldview, which is essentially that of materialism, philosophical materialism. And the sciences are now wholly owned subsidiaries of the materialist worldview.
Several decades ago, we found a problem so great that it was brushed under the carpet for many a decade. And this is the fact that galaxies spin too fast. We believe in the work of Isaac Newton, at least on planetary scales, but when you apply Newton's laws of motion to the galaxy spins too fast. In fact, 10 times too fast. By rights, the galaxy should fly apart. Therefore, scientists said that we have to have dark matter, a halo of matter that surrounds the galaxy and holds the galaxy together.
Between 1% and 3% of the universe is all the stuff we can see, and somewhere between 99 and 97% of the universe is stuff we can't see. This dark matter that dominates our galaxy, we think, we're virtually certain now, is made of some new type of elementary particle, different than the stuff that makes you and I up.
And what have they discovered? Absolutely nothing. Zilch.
What is a little bit perturbing is that after 50 years we still haven't found what the dark matter is. But on the other hand, that doesn't mean they're not there, it just means they're harder to find than we thought.
We look out in the universe and 85% of all the gravity that's out there has some mysterious unknown source. We add up all the stars, the galaxies, the planets, the comets, the black holes, the dark clouds, everything out there that we can see, touch, smell, or taste. And it doesn't add up to give us the gravity that we see operating in this universe. So really we should be calling it the dark force, because we don't know if it's made of matter. It could be a profound misnomer, sending people off in thought directions that might not really be the right path. So dark matter is just simply what we call this thing about which we know nothing, responsible for 85% of the gravity of the cosmos. We've known about dark matter since the 1930s. Back then it was called missing mass. That's what it was called. Because, there's got to be some mass. Where is it? We can't find it. It's got to be here somewhere, because we got the gravity. If you have the gravity, you got to have the mass. Mass and gravity go together. It's really dark gravity. Actually, we shouldn't call it anything. We should call it Fred. Something that has no meaning, because we don't know what it is to call it. But it is the longest standing unsolved problem in modern astrophysics. Dark matter, dark energy. Everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So, according to this chart, we are 96% stupid.
So the problem with cosmology is that we keep inventing theories, ad hoc theories, to try to explain the data, such as inflation, dark matter, dark energy, and so on, just to keep patching the theory up.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is why we're 120 zeros. This is the largest mismatch between theory and experiment in the history of science.
Physicists who make up the laws of nature are less constrained by them than most of us. And in the 1980s, people who were studying galaxies found that the galaxies weren't behaving as they ought to. these stars in the galaxies were revolving around the center far too fast, according to the amount of matter there should be in the galaxy. And galaxies were attracting each other too strongly to be explained in terms of the total amount of matter within them. If you add up all the matter within them, stars, planets, gas clouds, make generous assumptions for invisible stars and so on, there's not enough matter to explain the gravitational pull of one galaxy on another, or of a galaxy on its outlying stars. So there was a terrible dilemma. What to do? Either the theories on which cosmology were based, Newtonian or Einsteinian relativity and gravitation, were wrong, or there was some organizing principle in galaxies over and above gravity that scientists had missed out. Or there must be a lot more mass that we couldn't see within the galaxies that could explain the missing gravitational effect. Well, the least disruptive assumption for scientists was that there was a lot more matter that we couldn't see, and because we can't see it, it was called dark matter. So they postulated that there was dark matter in the galaxies that would explain these phenomena. The distribution of dark matter could be adjusted for each galaxy to explain its shape and its behavior. How much dark matter did each one have? Well, the answer is simple. You just titrate in as much dark matter as you need to make the equations balance and explain the form of the galaxy. And that's the prevailing view. There are still minorities in science who think that there have to be other ways of thinking of galaxies or modifying gravitational theory. But the great majority take the view that dark matter is real. However, the problem with that is that there's not a shred of evidence for its existence, despite billions of dollars being spent on dark matter detectors, underground pits full of fluids and so on. Not a shred of evidence has emerged that it actually exists. The only evidence for it is that it makes the equations balance and enables the conventional theories of physics to survive any test, because you can add in more dark matter or subtract it as required to explain what you want to explain. It's basically an untestable theory. They've tried to test it, the tests have failed, but nobody's given up the theory because it fits the theories that they want to believe in. Now, this led to a serious problem, because having magnified the amount of energy in the universe by about 5-fold through dark matter, there's far more of it than regular matter, that meant the whole universe had far more gravitation than people had previously thought. And that would mean that the expansion of the universe following the Big Bang, the expansion that's still going on, should be slowing down owing to all this extra matter within the universe. And in the 1990s, people thought that the universe would stop expanding, it would finally reach an ultimate limit, and then be pulled back together by all this matter in the universe gravitationally, until the whole thing ended in the opposite of the Big Bang, known in the trade as the Big Crunch. And the whole thing would end in tears. Well, that was the general view in the 1990s. But about 1999, observations of distant galaxies revealed that far from slowing down in their recession from us, they were speeding up. The universe was expanding faster and faster all the time. The exact opposite of the prediction of the dark matter theory. So, what to do? Well, again, you can't modify the fundamental assumptions because they're fixed. So, they did modify it in the sense that they said, well, there must be an extra form of energy pushing the universe apart. And we'll call that dark energy. And it's dark energy because it's undetectable by anything other than its effects, namely pushing the universe apart faster and faster. The problem is, this has now led to a tremendous problem for the principle of conservation of matter and energy, because the main theory of dark energy is that the density of dark energy is uniform throughout the universe and remains uniform. But since the universe is getting bigger, that means there must be more of it. So the universe is now a perpetual motion machine. It's actually creating energy as it expands.
When we think of Einsteinian physics, so it's relativity, which completely usurped Newtonian gravity and Newtonian motion. All right? What we call the era of classical physics, which led right up to the late 1800s, Newton's ideas reigned supreme. All right? And he told you what gravity did, what motion did, and acceleration in a pre-existing space, and it was working. Okay? It was working. And then people said, well, wait a minute. The orbit of Mercury is not really following Newton's laws. And we said, oh, we got this. We know we got this. There's another planet you can't see that's tugging on it. We even had a name for that planet. It was called Vulcan. Okay? Huh? A hypothetical planet tugging on Mercury so that we didn't have to throw out Newton's laws. All right? So that was invoked we just pulled that out of our ass, right? Said, there it is, we'll find it one day. Einstein comes along with his special theory of relativity and then his general theory of relativity. And what we find is that at high gravity, like near the sun, and at high gravity and high speeds, Newton's laws completely fail. You cannot use them at all. So isn't it true that quantum physics requires that space be quantized at some...
Quantum, excellent question too. Quantum gravity requires that space-time be quantized, but there might not be a theory of quantum gravity. We might look deeper and deeper, and instead of finding quantum bits of space-time, we will only find pure quantum mechanics with no gravity in it whatsoever. And that gravity emerges only out of the collective of tons and tons of these quantum interactions.
That's crazy.
So that just like water, it's like, yeah, it's crazy.
So the quantum interactions manifests as what we call gravity.
Right.
That's right.
The ensemble of H2O
manifests
as water.
Exactly.
Right.
Exactly.
And the same way you would pull out a single molecule, you're not necessarily looking at water at that point.
Right.
The same thing with the... Oh my!
You can't pull out a quantum and say, is this gravity?
Right.
Is this space-time anymore? Pull out a quantum and say, is this gravity?
Right.
Is this space-time anymore? Exactly.
Janet, you're saying gravity might not exist as a fundamental thing in the universe?
I'm saying gravity might not exist as a fundamental thing in the universe.
Wow.
I'm saying gravity might not exist as a fundamental thing in the universe.
Wow.
Man,
let's keep that between us.
Yeah.
Everybody else, you didn't hear that? You didn't hear that because I don't want to turn on the internet. You know there's no such thing as gravity.
Right, and now we're all floating.
Well, there's no such thing as gravity. I heard it. 10-11 told me. There's no such thing as gravity.
Somebody said to me recently, reality isn't overrated, but realism is.
I think I'm entitled. You want answers. I want the truth. You can't handle the truth. Son, we live in a world that has walls, and those walls have to be guarded by men with guns. Who's gonna do it?
Well, to make it worse, even in Einstein's description.
To make it worse.
I'll cover my ears.
I'm even looking at books on your shelf that might even talk about this. So even at the scales of big astrophysics, where space-time seems to be doing really well as a description, you can rewrite the entire theory of general relativity just in terms of particle interactions. You don't have to resort to the geometry of space-time. It's my preferred language, but as you see, there's a lot of extras that are required in that description that aren't necessary. I can simply look at it like I would any particle interaction. Two particles exchange a graviton, something happens. I don't ever need to resort to the whole beautiful geometry. I like to, I prefer it, but I can cast it as what we would call a field theory just as easily. So he showed that you can rewrite Einstein's theory of general relativity strictly in a field theory language.
Okay.
It's very nice. And so then, like, photons are replaced by gravitons, particle charges, electric charges are replaced by mass charges, and it works.